And Johnny's not here. He might want to watch that too.
It's your recording. Super 8.
Here, we'll guess what ride Johnny's on.
He's on a plane.
Oh.
Was he done already?
Yeah.
I'm gonna say he's on a plane.
Yeah. I think that's a pretty good guess.
Okay, cool.
I didn't see.
So I certainly did not prepare speakers or presentations. So we're kind of gonna yeet this. But like, maybe it's helpful to start here. I don't know. We'll find out. Generally, as a cute little structures workflow, you know, we're gonna be right about getting all of our inputs from performance and everybody else, what y'all have been doing, you know. So our performance is gonna get the loads from like your weight estimate. I mean, technically they're propulsive loads, but that's not super significant. If y'all are gonna mess with my screen again, gonna flip my shit.
I don't know what you're talking about, Becca.
I think it's your computer actually.
Yeah, it's kind of weird.
Okay.
I'm just drinking a LaCroix, so I don't know what's happening.
Clearly. Okay. So yeah, we're gonna get all these inputs. Ideally, we'd have material testing data. It's coming into the structural and the detail and everything. And for a while, that's just been like me. Ideally, this would be an entire team of people, you know, because there's a lot of different things to do. Some of the main structural elements are just going to be like the wing, the fuselage, and where to get out of here. Y'all are destroying me. And the landing gear and everything. So what we're usually going to start with is the wing, you know. And so, yeah, I don't know how much of this is obvious, but anyway, there exists this workflow. If you want to think about it, you can think about it. Otherwise, I don't know if we want to jump in like right away to like one of the things you want to do. I mean, to talk about detail at all and sizing it all, first you want to like define your components and ideally have an idea about what materials you're going to make them out of. And so I don't know how important it is that we like talk in detail about materials right now, you know. There is in the report from last year, manufacturing process selection that kind of goes through a little bit about the pros and cons of each of our materials. So a lot of times we'll use balsa buildup, interlocking laser cut pieces, you know, so it's pretty strong for its weight.
Have you ever done a balsa wood? Like you could have less balsa wood struts and then have a foam filled wing.
Are you saying just like what parts are balsa?
Yeah, like what? Like so, are you having like a balsa frame with like a cloth cover, or how do you actually build the wings?
Yeah.
There's a plastic, because I'm assuming the wings are either hollow or a very light foam.
I mean, it always depends on the year, of course, and you can trying to think where's a good place where I might have pictures. Well, I did get you with that. Okay. Here's the last balsa wing we did. We've got like this D box, and then this is all hollow, and then we sheet it with plastic. So that's a lot of time what our balsa wing looks like.
Okay.
I don't know. I think we've done that pretty much every
Right. Okay.
comp recently.
Right.
Yeah.
Okay.
We do foam for like prototypes and stuff a lot because it's fast, but
Yeah.
Now you're I forgot the name. That'll come to me. Your spar, has that always been wood, or can we like experiment with composites this year at all?
Yeah, we want to do composite things. Sometimes in the past, we've even done things like a foam wing with like, are you familiar with the terminology, all the components?
Somewhat. Most likely. No.
The same picture, but
Looking at that, no. I know ribs and I know the spar.
yeah.
Um,
Yeah, so this one's technically a C-channel construction, but it's pretty much equivalent to an I-beam. So you've
Right.
got your shear web, and that's a thin little bit. Then your spar caps, or in regular engineering, these are the flanges. That's the shear web. I think it's still called shear web in Aero, but spar caps. So the flanges. Yeah, so sometimes what we've done, I've seen a foam wing, and then so that'll handle like the shear, because it's like solid body, but then it's not strong enough for bending, so you can just put like carbon strips on top, like unidirectional. You can also do the same thing, just like put a sheet, like a little sheet of balsa if your loads are lower. But yeah, that's how you can mix it into like a foam construction.
What's the D box? Just quite curious.
Yeah. It looks like a little D, if you have an imagination.
Like the letter D?
Yeah.
Okay.
I don't know what you were thinking about, but yeah.
I want to make sure we're talking about the same thing.
Right. So yeah, just
I will be right back. Jack Catalano just came to the main room, so
cool.
Bring him here.
Yeah, he's mechanical, so.
Oh, great.
So is the D box just like the interior of the thing? Or is it just
well, it's what you call it when you wrap the foam around or
oh, okay. The balsa.
Yeah, when you
Okay.
wrap it around, so it just so it closes off, it meshes with the spar. I'm forgetting all my words today.
Yep.
So the spar, and then that sheet closes off, makes a little D. And the idea, did you not? Is he
no, he's coming. He said he's coming, but
sure, he might have lied. Yay.
Yes. How's it going?
What's up, Laird? How dare you skip out on my talk?
sorry, I thought you hit like, I don't know. I thought you were heading over, so.
How dare you? How rude!
I'm so sorry. I'm so sorry.
Boxes right now.
Oh man. What are we thinking for rapid prototyping? Are we still using 3D printing?
For
Depends,
what?
Yeah.
Just for the I don't know. I mean, we wouldn't make the final thing out of obviously PLA or ABS because stuff's heavy. But I mean, if you guys need, okay, what I'm trying to say is, if you guys need mock-ups on SolidWorks, I can definitely do that. Like, I want to do my part. So
yeah, I think it's coming up. I think we're doing that either this week or next week.
Yeah, and I've just been so busy. It's kind of I've been able to show up a lot, but I want to do my part, and and where I excel is doing 3D models. That's my game.
You say SolidWorks, but would you be mad if we did Onshape?
Onshape, I would not care because I can learn it.
Yeah.
I don't know what Onshape is. Is it just another? Is it free?
Yeah, it's more like Fusion, if you've ever used.
I know how to use Fusion. Yeah, I've
Mhm.
used Fusion
Okay,
before.
great. Because I'm very new to Onshape. I've used Fusion like once. I come from SolidWorks, but I think it'd be a really good move to move to Onshape. But anyhow, I think we're going to be starting CAD on Thursday. Right now, we're just talking about. I think we're going to get to be like material selecting for the plane, and then size the like wing spar for structures, stuff like that. So
The spar is like the main structural component. It's like the bone, right?
yeah. So here in this like balsa buildup here, it's actually C channel or equivalently an I-beam, you know. So you've got the shear web that's that vertical thin plate, and then you've got the spar caps or the I-beam flanges.
Yeah. So you're not getting any warping, so you have strength in both directions.
What was
Yeah.
that? Not SolidWorks. What was the other one?
Onshape or Fusion?
Is that on the AWS? I'm not seeing it at all.
Onshape is you can actually use it in browser.
Oh, that's awesome.
Cool.
Yeah, where is she be? She's over here. You might have to like have a day for them to confirm your student email, or I don't remember.
What's your password?
I don't know why you
Get our password like a Netflix subscription.
No, I have Netflix. I don't have Onshape though.
Yeah, so you can totally. Yeah. I'm
Perfect switch.
into
I'll give you the
this.
Netflix password for the Onshape password.
Well, no, like you know how like kids will like share their Netflix passwords. Like, hey, just take my password, bro.
I don't even know my password.
I don't even use
I don't even know my
Netflix.
username.
It's a whale.
A dolphin.
Yeah, something like that. Anyway, so yeah, everything's in here and that's cool, but we'll do that later. Okay.
Yeah, I love 3D modeling, so I guess I will self-assign myself to be. That'll be because I can't code, but I can 3D model.
Uh-huh. Yeah. Cool. Nice. Are both of y'all freshmen MEs?
Yeah.
Okay.
Me and Andrew have actually known each other for a while now, so it's pretty cool. Like showing up to the meeting, and I'm like, "Oh, hey, what's up, Andrew?"
Yeah, cool. I'm the reason Laird's here from freshman year. So you're welcome. Okay. Yeah, we were just going over a little bit of terminology, you know, so we're good about spar cap. D-box is when you sheet the leading edge, you meet it with the spar, makes a little D shape, call that D-box. Does anybody, it's a little spoiler, does anybody have any ideas why you might do a D-box?
Oh, well, as compared to just this ribs, I think it would give you some lift. Are you asking why we cover it with material?
We'll cover it with balsa because the rest is just going to be covered with plastic, so it's going to be less structural.
Because that's the leading edge, which means there's going to be a whole ton of force from air resistance on it, and plastic has the tendency to fold in on it.
Deform, right? Yeah, plastic.
Yes, so.
I mean, I'm thinking like plastic wrap, which is pretty flimsy. I don't know if that's what we were using. Probably not. Probably a little tougher plastic. But I feel like having a frame on the D-box is probably a good idea in case, you know, you run into like something. Although
I guess
Andrew's hypothesis is also probably a little more plausible because I don't think we're going to be running into anything at our skill level.
Sure. Yeah, so there is you definitely want a really clean leading edge. So you're right about that. And you don't want any flimsiness or fluttering or warping in your plastic wrap on the leading edge, because that's like critical for defining the boundary layer and everything, like following where it touches, and if you trip it to turbulent right away, then you're going to be turbulent and good fluids, stuff like that. Also structurally, there's a really good benefit to closing off shapes when you consider torsion. So have either of y'all taken CE 204? No.
It doesn't sound familiar. But I know what torsion is.
Well, that's great. We love that. Okay. Yeah, a lot of the like structures position, and granted, theoretically the mechanical team should be extended beyond single structures position, but a lot of that is your CE 204 and 207. But anyhow, from CE 204 and 207, those kind of equations, you can calculate things like this, and bending stiffness, torsional stiffness. So what you find is that the plate is garbage. And so that's your reference. So all of these have like the same material amounts. Your I-beam is going to be really good in bending, and it's going to be okay. Well, I guess it's worse. Yeah. So I guess it's worse than the plate in torsion. So your I-beam's garbage for torsion, plate's garbage for bending, and your closed box is pretty all right for bending, but it's really good for torsion. So
Real quick, because they haven't taken 204, what do you mean by bending versus torsion?
Oh no.
Because they are the same thing, right?
No,
Absolutely not.
Okay.
Isn't torsion like
aero major, Laird? Don't.
Okay, fair enough. I certainly wouldn't have known
Totally
before I
right.
took that class.
Here.
So
Torsion. This
torsion?
is bending.
Yeah.
okay, cool. Just checking.
Laird is like,
Buckling.
this, boys and girls, is an airplane. It goes flying in the air.
Hey,
It
I
has
didn't know.
a wing and a spinny thing called a propeller.
Look, that would have been news to me as a freshman. So
Because so it's torsion is this. We have bending is this. Buckling is going together.
I mean,
And what's the other one? There's one
Well,
more.
Shear,
Oh, shear. Shear is like
I got you, bro.
Cool.
Shear is shifting to the side, like that's shear, or like this.
and they teach freshman MEs a lot.
No, I'm just.
I saw that on Instagram.
Fair enough.
yeah, no, they don't teach us anything. But yeah, so y'all know your shit. We know that your bending moment and your torsion are computationally the same, but torsion is like on your long axis, right? So yeah, good stuff like that. Okay. Okay, yeah, so we know, yeah, so you can always keep that in mind. Boxes are really great for torsion because it's distributed through like all that things. You can think about it. So that's why we close this shape, right? Because I mean, I'm gonna get this wrong, so I'm not aero or whatever, but your like center of pressure is like not aligned with your spar. And so if your spar is over here, but your pressure is acting like net over here, then you're putting in torsion. So there are torsion loads. We don't usually calculate them, but we do this D-box, and then it's pretty much like, good job, we did it. So yeah, those are some design ideas to think about. Also, if we imagine you're bending, you want to separate those plates in your I-beam if you're looking at it. So the farther apart they are, the easier they can like resist a moment or hold a moment, whatever you want to call it, you know? So that's why you want your wing to be thick, because the thicker your wing, the farther you can spread that out, and then the less weight you need to put into making that I-beam structurally thick. So you can have less material if it's farther out from the neutral axis, and neutral axis is just you know, the one running that way. The middle.
What they say, thick wings save lives.
Is that what they say? Okay. Yeah, so I don't know. I don't want to go through this whole document. I wrote this document. You can read this document. There are technically some spaces missing, but I can throw this somewhere. Do you guys want it now? Maybe I'll just get rid of that and pretend like it's a final document. Is that an option? Let me see if there's anything else weird.
What do we use to cut the balsa wood? Do we just use a laser cutter?
Yeah, we got a laser cutter. It's super great and we love it. And it looks like that.
Wonderful. One question though, why don't we make the plane out of foam?
We can. Foam is weaker, if you can imagine. And it's actually heavier, and stop messing with my screen. Freaking me out. Yeah, so we'll often use foam for like prototyping, but it does end up being heavier because you have to make it solid or else it'll not be structural for shit. But yeah, it's really fast for prototyping, and I wrote a and the please make it go away. How do I? It's over here, right? Okay. Okay, where is it? So now I'm in annotate. Stop annotate. Okay. I write words about the good and the bad of the things, and it is in the design report from last year. So these are words. So
This is news to me. I've never seen words before. Can you read it to me?
no.
Oh, I can't read it myself.
I will not read these two.
I'm in fact illiterate. That's why I go to Cal Poly.
I know there is no essay requirement for the application. And so all Cal Poly students are illiterate.
Isn't that right, Andrea?
Yeah, it's, you see no one wearing masks. They can't read the rules. Yep.
Okay, so yeah, where are we at? Do we want to size the wing?
I got a question.
Yeah.
We don't put balsa wood over the entire. We just put it on the front leading edge, right?
If you really wanted to, you could do the whole thing.
How are we gonna do control surfaces?
You know, by doing them. Wondering if I have.
Wait, did you say by doing them? Kind of.
Of course, just do them. You know.
Oh, so we have balsa wood control surfaces.
Sometimes if you want to. So the thing is, theoretically, you could calculate every single thing on the entire aircraft and do your stress analysis and find the stress in every single thing, and that would properly, and then try it for like all different configurations possible, and then find like the lightest weight scenario that doesn't break. But that is a lot of computation, that is a lot of time. So I've been the only one on the structural sizing team, and there's not a whole lot of like methodology built up around it. And so I'm not going to do the entire plane. If we get more people, we can definitely go in depth on more things. But a lot of time, intuition knowing those basic design principles that we were talking about, like about what's good in bending, what's good in shear, what's good in torsion, and then like experience working with the materials and what you want it to look like. If you really want to, you can make a plane that just looks sick as frick. You can look at a plane that you want to like mimic, you know, if you see somebody's DBF or other RC plane, you're like, that looks super cool. That would make sense to do here. You can do it.
Also, another question.
Mhm.
For control surfaces, how are we doing the joints between them?
Yeah, a lot of times I think we'll use little CA hinges.
What's a CA hinge?
Yeah, it's like a little fibrous piece of paper cloth kind of, and there'll be little squares.
Okay.
So you can like slip them in, and then you do some CA glue, and then it like permeates through. So it's
acrylate.
yeah. Yeah, a lot of this we use CA glue for everything. So yeah, that'll just be a little flexible hinge. Yeah, I don't know that we really do anything else.
Okay. So I know for foam, you can have some like, there are different ways for doing foam, but this is not foam. Now I was just curious.
Yeah, I mean, you can do whatever you want. You really can do whatever you want.
Let's just make a plane that just looks like absolute dog shit, but just flies amazing. Like just the weirdest looking plane, but
Here's the thing. Here's the thing.
It flies good.
We've tried. Ooh, this plane will be great, and it looks like crap. And you know what? It's never good. It's just never good. And looks good, flies good is like one of the biggest principles. Yeah, like legit. Looks good, flies good.
Unfortunately. Yeah. So yeah, you can see we've got little and no offense to Peter or whatever. Me and Peter did this CAD like the night before. But we have these little servo guys, and so we'll put them in between the ribs or whatever, and then we'll run like a just a little wire. What do you call it? Push pull wire over to some little one or whatever.
those little thingies, flight thingies.
Yeah, I mean, I'm not Arrow. I don't know the words. So yeah, and so
They have like multiple holes in them, and you can switch out. Yeah, I know this.
Yeah, so that'll be that.
Like
the rest.
Is that what you're thinking of, Andrew? A little plastic bracket?
Basically, they just has different holes for you can.
Yeah, it looks like a Lego piece, like those Lego pieces that. Yeah.
Well, you can change the how much you want the.
Exactly what you're talking about.
It's
It looks
depending
like
on how far away from the control surface is.
Yeah, I'll draw it right here on my notebook. Actually, I have a notepad right here. I'll draw it just because I want to feel smart.
It just looks like a T, and it has. Or
See,
it,
like
there's
this.
Yeah.
And each hole can adjust the moment arm.
Yeah.
Tell me, what is that?
Moment arm is the distance from the.
No.
Oh.
Here. Well,
Yeah. So yeah.
Keep moving the drawing. I'm trying to draw it on. No, it's fine.
Man, that's an engineering drawing that Larson would just like drool at. That's so nice.
No, it's kind of garbage. You should see last year's. And by last year's, I mean not last year's, but the one before. It was super sick. I wonder if we still have it.
I just like it because it has lots of nice colors.
Well, all the old
I
reports.
bet y'all don't do this to Jake. Y'all are being unfair.
I'm not in Jake's room ever, so I haven't been able to.
Okay, 2020.
I was doing it to Larry.
Yeah.
I mean.
He was doing it to me.
The plane. This looks almost exactly like the plane we designed last year. Because we can commit to disaster.
You didn't have to be so aggressive about those air quotes, Becca.
think I did. I think I did have to be that
Fair
aggressive.
enough.
But, yeah, so this is the plane and it is in the air, and this is the microlight.
That's
So
the wing, right?
this is the plane.
Oh. Oh, okay. I thought it was the wing. I'm sorry.
Okay, yeah. Like entirely balsa construction. That's what we did before, but are you okay? Where's our, is it here?
5.6.
Okay, she's so pretty, guys. I tried so hard on this one. This is gonna blow your mind.
Question. If you go to that picture up above.
No, this is
Up
important.
above.
Blows your mind.
You know, it would blow my mind if you went above to the picture. For right here, those and right here, is that for this, like the, I don't know, it's not the tipping point, but it's like your
center of mass.
Yeah, over the wings. Is that
Yeah.
Center of lift.
okay?
Yeah. It is not the center of lift, it is the center of mass. SolidWorks will compute that for you. This was done in SolidWorks, unfortunately. So yeah, you draw it because you want this CG to be pretty close to quarter chord / where the spar is / where the center of pressure is. That is the servo. That was the servo for inside the plane. There was an internal mechanism, and we just threw it in the wing because we could, and so it was
Oh,
controlled.
it's to drop something.
But yeah,
Yeah.
we had
Why is it called a max bush?
uh
That sounds like something you should probably like get rid of, or like freaking like trim or something.
Yeah, trimming would have been good on this plane. No, we every year we have a good name, or we try at least.
Okay.
this was not a
I can tell. Yeah.
This was not our best work. I think probably marginally better than eucalyptus rod, but
we've been doing bad. We
Yeah.
have other such names as fits inside and swings both ways. And what are some other good ones?
you're forgetting the best pack in 9 inches. We've got balls deep.
Yeah.
Yeah, balsa deep. Balsa deep. How about
Nope,
that?
just balls deep.
Oh, okay, but it's made out of balsa, right?
It was, but it also carried balls,
Oh, okay.
like
So
golf balls, and so it was balls deep. It's
okay.
inside, had to fit inside of a tube. You had to like fold it up and fit it inside of a tube.
Oh, I remember that. I saw that one at USC.
Yeah,
I
yeah.
saw their
Do other teams also have names that are a little
Great. Are
over the
you?
top?
USC always puts like the letters USC, I think, in their name, right? They do some weird shit.
I don't know. I've never paid attention to USC. That's a lie.
So can me and Andrew think of the name? Actually, no. I probably have the dirtiest mind. So I would suggest that maybe I can pick the name. Like I could mold over with my dad or something, like.
Y'all can definitely keep with yeah, you can practice on your own aircraft, find a tangentially related sexual innuendo.
Okay, good. Because I would call it like slippery when wet, or like I don't know, like what else? Like just something really creative, like
with the,
Oh no, because we're trying to do something with containers. We could do like fill me up.
like how about like drop the load and
But we're not dropping it.
Drop a load and hit the load. Drop a load and hit the road. I think I like that one actually.
But that would give us disqualified.
Okay, wait. What about like carry a load?
Dropping a load? Yeah, that would layer.
Maximum payload.
Sorry. You're right.
Maximum payload. I like that one. Or like, yeah, I kind of liked it actually. And do you
What
have any
was-
suggestions?
Yeah, fill me up, Daddy. That was the
Fill me up. Oh, that's a good one. That's a good one.
putting it into yeah, okay.
What about
Wait,
the
question.
Jenga Banga?
What was the purpose of this plane? The max push.
I don't know why they called. Oh, it was a bush.
It was a bush. It was a bush plane. Yeah.
Was it minimum takeoff distance?
There
There
was
was
a
a-
minimum, wasn't
Or not minimum,
measured.
like you want the shortest takeoff distance?
It was 10 feet.
No, they didn't. Yeah, they didn't score on takeoff, but they imposed a short takeoff.
So what was the purpose of a bush plane?
It was a banner. It was a banner
Got
towing
it,
bush
okay.
plane, and so it was banners, and they scored on like a banner length and stuff like that. And then
Interesting.
there was also just like a passenger payload as well. There were two flight missions that were like scored.
Got it.
That's
What's
cool.
that rod underneath it? Just curious.
That's probably the eucalyptus rod, right?
No, eucalyptus rod was this most recent year. That was the banner, right?
Yeah, that's the banner all rolled up.
Oh,
Oh,
wait. So do you deploy it in flight versus?
Yeah.
Oh,
Yeah. It's got a little weight for stability or something.
yeah. I see that. I got a little tip. I like it.
Yeah. Okay. We need to calm down. We shouldn't have talked about the naming convention.
It's true.
it's all going on YouTube, so
I know.
I'm having the time of my life.
you're a little deeper.
I'm gonna have to head out because I've got a study session in 10 minutes.
I
But
just don't want to talk about our plane names with us.
Andrew,
I'm
we will,
sorry,
we will continue this conversation later.
I'm certain. All right. See y'all.
Right, so-
Good.
Rebecca's like, don't leave me with these strawberries.
A little bit.
Sorry.
Okay. This is from Laird.
So, how's the weather?
It's all right. Weather's all right.
Uh,
Yeah.
Okay.
oh,
Yeah. If you have questions, are we gonna
Yeah.
size the spar someday?
no. For wheels, are we attaching those with also balsa wood?
Attaching what?
The wheels.
Wheels. Oh,
Yeah.
no.
Mhm.
I don't want to.
You're not going to touch
Oh,
those.
wait, so we're just not
So-
gonna have wheels?
These were the dumbest legs ever.
Right.
That was the worst idea ever. Somebody told me to do that, and then I did, and then everyone was like, "Why did you think that was a good idea?"
Wheels suck.
So
Yeah.
For this plane right here, that's just straight up metal, right?
Yeah, that was
And
just
that's something we're gonna do too.
Yeah, boy. I'm thinking a carbon composite, like
Okay.
arcing guy. Because we want to do, I think it would be a good test once we can get in the lab to do a little carbon composite wet layup. We saw from USC did it like last year, and then I think you should be able to like bolt it in from the bottom to a hard point on the fuselage or whatever. And I
Okay.
think that'll be a good option. We can swap it out in multiple prototypes. You know, that other guy was like fixed. And well, both of these would be fixed to the fuselage, but I think we should have removable composite gear.
Right. You said we're
These
taking off from asphalt, right?
Yeah.
Okay. So wheel size doesn't really matter.
We should probably get like some squishy wheels because those will be able to like, I mean, you can like stabilize without having suspension. You just get those rubber squishy wheels or foam squishy wheels. They're light. They won't pop, you know.
Yeah, I think we should get some thickier wheels than we have in the past. So you're totally right about damping. When you have because we don't have the complexity to put like shocks on it or whatever, you know.
We don't
So
need shocks.
you can throw that into the tire, you know, and that'll decrease the like impulse force, you know, and so your legs won't break and you won't transmit a big force through like the rest of your structures. So yeah, thicky
Right.
tires are good.
Um,
Some bitches will say something about arrow, but whatever.
Can you go to the other plane? Is there one that's looking straight on it? Yeah. So also having those like the kind of a triangle more would also increase some of the shock absorbance too.
Yeah, that's smart.
If it's
So you
metal.
can get a little moment arm going that bends, a little bit of flex there. I like it.
Yeah, there's a balance between so for this guy, the prop was kind of close to the ground. So this is like a sideways prop, but the actual prop goes all the way down to here, you know? And then so you don't want the prop to hit when you're landing. So your landing gear is going to deflect. And so you want it to deflect, you want it to be elastic, but you also don't want it to be weak or to deflect too much and then you hit the ground, right? So there's a little balancing act for that, but you can definitely run calcs on like the stiffness and the deflection of your landing gear and stuff like that. So good things to have in mind. Did y'all have, so again, these planes, I'm disappointed. They look very similar. And I worry that the plane that y'all picked out also looks very similar to this. And I think we're in DBF, we're getting into a habit of just making the same plane over and over again. And I think that's kind of boring. So
What
it's
do you-
really,
What would you recommend for like changing it? Because I guess I mean, unless we're doing like a fast flight, right? These are all gonna have like they need the lift and stuff. And I think ours are gonna be different. Our plan is gonna be different because we're gonna have a wider fuselage. But I think you're right, having like the similar wing and.
I mean, if it ain't broke, don't fix it. But
you say, but then it limits our like ability to think creatively and also.
I mean, don't worry. We got Vlado on our team. He's like, hey, yo, what if we put like a ramjet on there? So
he
I
says
mean, like,
the craziest shit.
Yeah, probably crazier than I do.
He's like, can we have the fuselage like retract in air? Why would you do that?
Yeah, let's get like, can we have a fuselage that has a machine gun to shoot down the other planes and get us better score? Can we have saws on it? So in case it hits people in the air, it'll cut them up.
Yeah.
Don't we fly one at a time?
What?
Don't we fly one at a time though?
Yeah, but we can like shoot the planes on the ground. Sitting ducks, you know what I'm saying?
No.
All right, I'll jump to side. I feel like having some fresh brains, some fresh meat in here is gonna, like me and Andrew, you know, we got like under new management, you know, get the boomers out. Sorry, Rebecca. We'll bring in some new and improved ideas.
Oh my, yeah.
And even more sexual names to the team is what I'm saying.
Honestly scared. But yeah, so we want to be innovative. We don't want to get caught up in this box. Yes, it is very simple to manufacture and there are a lot of benefits to it. It's pretty lightweight. We know how to use balsa, but also, yeah, don't let that limit you. Don't like see two of our planes and then be like, that's what DBF planes look like. It's easy when you go to competition, you get to see everybody's making their own different planes. And I know that some of them are releasing videos like on YouTube and stuff of their reveal this year because there's no competition. So you can definitely look around other RC planes, other DBF planes, and be experimentational. And I think that'll be really good for the Mechie team.
Side note, I am also an okay videographer. Mediocre. I have my YouTube channel, which kind of blows. Not that good, but I can make videos. So if you guys would like me to make a video concerning our dog shit plane, I would be elated.
Oh, good. Good.
If we just look up DBF planes, would that be like? Is that good?
I mean, you can't go wrong with looking up DBF, to be honest. Like, I think you'll get the DBF club. I think that'll work.
Jake,
Jake,
you got
what do you
something?
want?
I finished, so I don't know what
You want to help us
harass?
harass Rebecca?
Honestly, I feel like I've had my fill for today, but that's up to you guys.
We've been at it. Yeah, it was.
Trying to destroy me. So are you leaving your kids? Are you?
I'm not leaving yet. I'm pretty sure I'm supposed to go eat dinner soon, but I don't know when exactly. And I also don't know what happened to Laird, but
He left.
Oh,
Yeah, no, we drove him away. Larry bailed.
Where does study
Good.
session?
lame. Understandable, but yeah, I'll just go back to the other room and then leave eventually.
Maybe
But
something.
they know
Yeah.
how to design tails now in theory. So
Get that airfoil selected.
I think that's what they're doing.
Okay, yeah, help them. Yeah, we can.
Okay, bye.
Bye.
Hi,
Yeah.
Jake. Wait. Okay. I feel weird calling you Rebecca because everybody calls you Becca. Which do you prefer?
It's whatever. Like, what's in a name? Who is self? What is identity?
All right.
But
I'll
a
call
lot
you
of people call me Becca, so you can do that if you want.
What's your major?
Mechanic.
Oh, she's one of us. She's one of the boys.
We're all the
You
same.
think I made this sexy ass drawing package as an arrow major?
Yeah.
I don't know. I didn't think that because, damn.
It'll blow you away. You should see the previous years. Literal garbage. Okay, so we're here to fix all of the arrows when they don't know what they're doing. So it'll be great.
Yeah. You can troglodytes. They can't even. They're like, oh, plane go fly, and then they can't.
Yeah.
Do anything else.
Okay, so I'm going to show you guys the spar sizing because that's one of your main decisions is making a spar. This spar is technically balsa, but a lot of the methodology will carry over if you're doing some other method that we talked about. So yeah, here, I don't know if y'all want this in the place and things.
We'll probably just straight up use it and we won't copy anything over. Like what we did with the last stuff. I'm also looking at the question.
Yes.
It says via video. Is it in Arizona or Kansas?
What is?
Is the competition in Arizona and Kansas, or are they the ones that video though?
Every other year, the competition switches either in Tucson, Arizona, or Wichita, Kansas.
Okay, that's fine.
Yeah. The most recent competition was in Tucson.
So let's go to the most sparsely populated states that don't exist.
No, because I was looking through it and it was like Arizona, Kansas. I'm like, why do they keep winning every single year? And I got very confused.
Big brain.
Where might I have put this? In structures, do we think? The end
Montcalm.
landing.
They do it in Montcalm.
No, I'm trying to find where my file is.
Oh, you can search it.
Wait, it shows over here, doesn't it? Structures, wings, processing. Structures. Where did it go? I swear, we were just there.
It's right there. It's up.
Losing my mind. Structures, wing. It's processing. I guess I don't know what that is, but I can throw it in there. Why is it not here? Is it not here? I'm looking for, am I losing my mind? Do y'all see what's going on?
Now I'm looking at a report from last year.
I see OSIF hours. I think that's pretty cool. You must have been really slam bangled when you wrote that.
What's Clarkson University?
Asif is intentional. I have no idea about the thing that you said that.
Oh,
What?
it's flambangled. That just means you're drunk as a skunk. My dad taught me that word. I think it's funny.
Spar sizing 20. That was so hard. Okay. It's there. Okay, so also I use .mlx files instead of .m files, and everybody can fight me about it. Deal with it, okay?
What's the difference?
You can type just words inside of it. And also the things will read out here instead of like popping up in 8 different windows.
Right.
Why would you ever use the other one then? This is so much better.
Exactly.
Um,
So what you can also do is you can have a main file and then you can have your functions and you just put them at the bottom and then you don't need a million files, right? So then you can't access it from other files unless you make a new function. So there are pros and cons, but you know, do what you want.
I gotta say, some of these plans are pretty cool. Looking through the winning reports.
Yeah, it's a good place to be.
Damn, cool. Okay, sorry.
Okay. So through this in the mock comp, what you do is you get stock pulse sizes. Everything is in inches, pounds, force, PSI. So we've got 30 seconds, really the thinnest we have, and then you can go up in increments of American increments and you know how it be. So what's the okay, so if one of y'all wanted to grab this, you can put in your numbers, is all of the numbers that you have. I don't think you have all the numbers yet, but your aspect ratio, you can update that. Your wingspan, that'll calculate the chord. Then you need the thickness, the max thickness of your airfoil. And I guess maybe I should tell you guys a little bit about C204 if y'all haven't taken the class. So we're gonna do a little teaching moment. Okay, so this is what we're doing. This is a beam. And this is
a cantilever beam.
It is a cantilever beam.
I get a gold star, Andrew.
Yes, you do. So theoretically, like the ideal lift distribution is elliptical, right? So this is actually half of your wing, and this is the connection to the fuselage, but we're modeling it as a cantilever beam. So this is your lift. And so of course this is going to deflect your guy like this. But there are these fun things. So you get this lift distribution. And we call that W. For
Are we
whatever.
looking straight on at the wing? We're not atop of it.
This is what I'm drawing. This is your plane. That's your wing, right?
Okay, cool.
Because the lift is up.
Right, yeah, I was.
I don't know if anyone told you that. I'm kidding. Okay,
No,
so
that's news to me actually, that lift is up. I thought it was down, to be honest.
okay, so then you're gonna get your shear force, and we call that V. And that is gonna be the integral of, and I'm gonna call this X, why won't we? So that's the integral of the distribution dx. So I'm really bad at math, so I have no idea what that's gonna look like. And then you're gonna get your moment.
It would be all above the X, wouldn't it?
It's gonna be
Oh,
something.
wait, that's the shear. Never mind.
It's gonna
Sorry.
be something, and then we're gonna get a moment is the integral of your shear. And that's also gonna be something, and I don't know math, so it's gonna be something.
Was it just a double integral?
Sure, if you wanted to. If you wanted to skip a step,
Well, is that how you calculate it, or?
you can calculate it however you goddamn want. But yeah, so usually like in class, you'll be given like an easier, like a constant distribution or something like that, you know, because we engineers are garbage at math. I don't know if anyone told you. This is actually what it looks like. So this is an ellipse. This is the integrated shear force. This is the integrated bending moment. You see that your shear force and your bending moment have the greatest magnitude at what is called the root. This is where you connect with the fuselage, your armpit, the root. So if you imagine, if you had a cantilever beam and you load it, it's not gonna load, it's not gonna break right there, but it is gonna break down there at the base, you know? It's gonna, unless you have some weird material, you know, if you have like a void somewhere, then sure, but you know, whatever. So yeah, so these are math things, and I don't particularly want to bother getting into that because you're just going to take a class on it in a little while. But you know, yeah, so that is the integral of that. So what we do, so after, okay, so here's your aircraft parameters, your weight and your load factor that you guys have theoretically already found. Your safety factor. Are we familiar with safety factors?
That's the amount of like air you can have. It's like the amount that you want to build it for, so that if you go over your max, you have enough like strength to withstand that going over.
Yeah, that's the right idea. So your safety factor is
Is it
how
10%?
much it can take, and then over how much you give it. And let's hope that doesn't sound too sexual either, but so you might call, that's like the strength. Some people do an S, maybe it's the yield strength, SY. And then this is like the sigma applied, right? So sigma is stress. Okay, so yeah, so you have to have a safety factor of 1 means that it is breaking when you fully load it. Safety factor of 1.01, it means you're really testing your luck. Anything above that, so your safety factor is supposed to account for if you don't know your material properties very well, if you don't know your loads very well, if you think that there could be voids in your material, or that failure may be caused by something else. So yeah, that's the kind of buffer you want to get it. So you can
Like
choose this number.
Right?
Huh?
It's just a safety net, right?
Yeah, yeah, but it's essential. So unmanned aircraft will typically be like 1.15. It's really low. It's about as low as you can get, because if you crash, no pilot's gonna die.
Wait, say again. What was the
1.15.
or what was the it's not a Boeing, it's a what kind of plane?
Unmanned, no person.
Okay, cool.
There might be a woman in it though.
Oof.
It's going on YouTube, Jack.
That's not even bad.
Okay. So then aircraft, like commercial aircraft, might be like 1.5, which is still pretty low, but it's kind of necessary for it to get in the air and not be super heavy. So what they do instead is you have redundant systems so that your things don't fail, and if they do fail, you have backup. You have some way of not dying immediately, and then you have to keep up maintenance. So you can do 1.5, but it's still pretty low. Granted, 1.75 a lot of people think is even high for DBF, because there's like zero, there's like zero tragedy if you crash, you know.
Right.
So you can totally lightweight it if you really want to. You can
Motto's like challenge accepted.
You should tell
Right.
the redundant systems to Boeing. I'm just saying the planes that they make, I think both of those planes that they made flew over my house at one point.
Mm-hmm.
Kind of scary.
Oh, the ones that crashed?
Yeah.
I didn't hear about this, but I forgot. I guess I don't look at the news. I guess I'm too busy playing video games, but yeah.
It does happen sometimes. So yeah, but I was suspicious about having a really low safety factor because our material properties vary a whole lot. We haven't done material property testing. So there, and then the loads, we don't understand our turning model. So there's a lot of unknown. So if you want to be conservative, you can have a higher safety factor. So that's your decision. Here's some strength properties, and then like we were saying, you divide it by the safety factor to see what's allowable, how much you're allowed to load it. Okay, so then your lift on one wing is half of the lift that's on the whole thing. These are just equations for an ellipse. You don't have to touch that if you don't want to. And then you're integrating manually cumulative traps, also known as cum traps.
Nothing.
DBF is a disaster. You have to understand. This is a disaster. And it is cum traps.
I really don't think it could ever get any worse than that, but I really think I'll prove myself wrong. I will find that there will be something else in this club that really just blows my mind.
Good luck. So yeah, these are just ellipse equations and it's math things. Then you have stress equations that you will learn about in 204. So you have the shear web thickness you can calculate from the shear force and the like cross-sectional area, things like that. What you're gonna do though is we had all these stock sizes, right? We know if we're building it all out of balsa, our thickness of our spar caps have to be a stock thickness. And so we run through all of these options in this little for loop here. So we calculate a bunch of different I-beams for the different stock thicknesses. And then we want to select the correct one by weight minimization. So then we take this, we calculate the weight of each of our options, and then we're going to plot the options, right? So the only variable we're changing is the spar cap thickness, and then we're going to get the weight of the entire spar cap. So what you see here, huh?
Can I ask a question on this?
Yeah.
Does the spar caps, do those provide any like structural strength, or are they just for building purposes?
They are the bending strength, right?
Yeah, so like the top and bottom of the I-beam, right?
Yeah. So
right, but why are we just, or would it be later? There's something that has to do with the force of, or like how much weight you have.
So, so the stress on this beam is, we have shear stress, tau, is VQ over IT, and those are things. And this is shear.
Okay.
This I is the area moment of inertia if y'all took statics.
Nope.
No.
Oh, I am failing that right now. I'm just joking. I'm taking it, but not failing.
Okay,
That
super
was a
rad.
joke. I'm smart. I swear.
So that's kind of that's about kind of the like geometry stiffness of your cross section.
Okay.
it's things.
Right.
You know, I don't want to teach you like the whole class that you're gonna
Yeah,
learn.
very
it.
good.
So ideally y'all will get like a design intuition and y'all will know how to operate the code. And then once you take those classes, you can develop your own methods, you know, but this
Right.
one's gonna be your moment times, this is your neutral axis. Up here, this distance is C. So that's half of your thickness. And then again, over the same I. And so like we were saying, you want to space those plates out far away because that increases, well, it technically increases that, but it makes your eye stronger, right?
Got it.
So,
Okay.
yeah, that wasn't a very good
Very
representation.
good.
But
Good.
the idea is that this sigma normal stress, the bending stress, that's held mostly by the caps.
Okay.
And then your shear is held mostly by the shear web.
Right. Okay. Cool.
So it's that there are those like two stress states. And so you need two different kinds of elements to
Right,
handle
okay.
that well and efficiently. So,
Got
okay. So those are the equations that get the stress and everything that the script is using. But what you're going to find out is that this wants to trend towards zero infinitely, you know. So what it wants you to do is have infinitely thin spar cap thickness and have it be infinitely wide, you know.
Okay.
So that's not shown in this graph per se, because we're not looking at, but it's calculating the width of the cap. So you give it, you say, what about this thickness? And it says you would need this width to do that. So
Okay.
for weight, it wants you to have an infinitely thin thing, but then you would protrude out from your airfoil, right? So you've got your airfoil boy and you've got to fit, so you can, so you want to place it at the thickest point, you know, because we were saying about the things. So you want to put him there and then you can, he looks all right, right? But then it wants you to do this, you know, and then have, I guess you would have approximately the same shear, but it wants you to be really wide. But then you're going to be like, that's outside your airfoil shape.
Right.
Which is nasty. So what you do is you choose a reasonable one. So I tried the different width of the caps in my SolidWorks model. And I said, that's the point at which it's acceptable, and beyond there, it's kind of gross. So
Anything for more thickness is okay, right?
yeah, so you work
Okay.
on the right side of this,
Right.
but there's no
Okay.
reason to be heavy when you don't need to.
Right.
So
Right. Okay.
minimize that as much as you can. That's pretty much it as far as this goes. If you are doing something different, like if you're doing a foam wing, then your material properties are going to be different, and that computation might look a little different. But that's the methodology.
Right. Question on reducing thickness of your not your airfoil, but like I guess like reducing your spar maybe. Could you have like struts for certain kinds of planes, of course, to strengthen your bending force?
Oh, you're thinking of slapping some guy wires on there, right? Or some struts.
Well, we can't do it for our plane. But
Oh, no guy wires?
I mean,
So are you saying,
Jack, we have a low wing.
Yeah, you're right. We can have struts though. Although they could be heavy.
I think for our plane, I was curious, like for other planes, have we ever had struts in the past to decrease your weight?
I'm not sure if
Will
we
it
ever
work at all?
had, I don't know off the top of my head what that competition would look like either.
Struts are can slow you down quite a bit, so a lot of drag.
If they're built correctly. Because
Yeah,
you can also,
building a correctly shaped strut is gonna be such a pain because you have to make it look like a little like nacelle, like have an airfoil shape in itself, and that just sounds like a big pain in the butt.
I think we're thinking about two different things.
Maybe I am one to do that.
Okay.
We're thinking about struts being low
Well,
gusset.
yeah, usually it's on a high wing plane though.
Nope, that's what I'm thinking of.
That's what I'm thinking of too. You don't have to have a airfield though.
Yeah,
Well,
but
minimizing drag. Have you ever seen that like NASA?
you have to have a teardrop shape at least.
Yeah.
I saw a cute little GIF one time that was showing the like drag caused by, or the disturbance in flow caused by like this single point versus like a larger airfoil shape.
Right.
But the air hits this and then just like flips its shit, right? But it'll stick with this guy. And so even though there's more like frontal area and more area for like friction drag and everything, you wouldn't want to underestimate the significance, even if you have like wires that you're like using for controls. Like if you have a you're like pull on the tail, even just having those wires exposed, some people think that's like a big no-no about drag, you know. And so you'll even see people with like tubes that you'll run a wire through and you'll hide it inside of the plane, so it's
Right,
not
yeah.
external and making drag. And so yeah, some people think this whole point is a really big deal. You can make decisions about if you think that's correct or whatever.
Yeah, that's what I was trying to say, Andrew, that like you'd have I just misspoke when I said airfoil, because airfoil implies that you're
Right.
going to take lift from it. I meant more like a teardrop shape.
Yeah.
Neat. And you can have a symmetric airfoil that wouldn't necessarily produce lift, at least if the like flow is directly parallel to that. So yeah, that's the situation. Do we want to start selecting materials for your aircraft?
Also would.
I hate to dip on like such a good time here, and I'm not being sarcastic. Like I think we actually got some real good stuff done today. At least I think so. But I have to do homework and talk to my friend who called me about an hour ago.
Yeah.
So
Oh,
I must dip.
sounds good.
But Andrew, we will discuss this later between ourselves because we are basically like the new gen
Well,
structure.
you just come to the meetings. We'll discuss it at the meeting. too.
Yeah, but
Be here next year.
what?
Yeah, Becca's gonna
Still
be
gonna
here
be
still.
here next
She's a
year.
third year.
Wait, Becca's a third year?
Yeah.
Everyone in the club.
Okay.
There's no seniors.
I thought you were a fourth
no-
year.
No.
Mm,
You can't
Oh,
get rid of me that easily. Y'all, if I was leaving you and there was nobody who knew their structure shit, I would be going so much harder on you guys. Like,
Yeah.
yeah,
All right,
it's gonna
sounds
be
good,
okay.
all right.
There's a lot of learning to do, and we can do it all the time.
Yeah, well, yeah, I guess I want to do some work I actually no, I'll have time on Thursday, I guess too. I hope at least to show up and have another little powwow with you guys.
Hey, Jack, what are you doing? What were you doing last night?
Was I in last night, dude? I was like doing work. Actually, not really, because I mean, it was weird. I was like,
What were you doing at 6 o'clock last night?
dude, what was I doing at 6 o'clock? I don't even remember, but I knew I was some sort of conflict where I couldn't go. I think I was trying to work on homework and like desperately trying to get myself to do homework, and I was like, yeah, I'd rather do homework and actually get stuff done than like go to like, because homework comes first, to be honest.
Right.
But I need to show up more often. Geez, SolidWorks is tweaking out right now. I'm sorry. Sorry, what were you saying, Andrew?
Nothing.
No, go ahead.
No, I didn't say anything.
No, you know what? I don't like your tone, bro.
Sounds good. Okay, we're gonna talk about materials now.
All right. Hey, Andrew, just let me know later what you guys decide on so I can start brainstorming, okay?
What? Okay, sounds good.
All right. See ya.
Cool.
Did you want to stick around, or are you gonna be out?
I'm good for
Okay.
a couple more minutes. Here, who else is in the other breakout rooms? If we only have like 4 people, then...
Everyone's gone.
Oh, where's Jake?
Gone.
No, he's here. It says he's here.
I don't see that.
Look in the breakout rooms. It says Jake's here.
No.
Does it not say that for you?
Yeah, I'm sharing it on my screen. Does it not show?
No. Nothing from Zoom shows on your screen.
That's so weird. Okay, yeah. Earlier y'all didn't respond to something I showed you, and I was like, what's going on?
Oh, yeah. No, it says me, you, and Jake are all in the...
That's weird. Yeah, I'm not seeing that, but Jake said he had somewhere to be.
Okay.
But yeah. Okay.
And I was just so I'm thinking we're doing like balsa for our wing, right? And we'll have probably, I'm assuming, some plastic, unless we have, could we do like a thinner balsa wood on the tail edge of the airfoil?
If you want to.
Okay. Is there a
It's-
difference in that and
Well, the
plastic?
thing is, it's assumed that like all your load is going through the spar, and
Okay.
that everything else is just for the airfoil form. So theoretically, you can make the spar less thick, considering the contributions of like a structural skin. But the calculation would be a little bit harder because
Yeah.
the thing is the airfoil is defined by like points, and so you can't do math on like a set of points. So yeah, I mean, a lot of these methods are underdeveloped, and if you see a place where you can develop it, that's a big move. But
Okay.
yeah, so I'm not sure I would recommend it if you are going really fast. So another option is like a foam wing that you put like fiberglass over.
Okay.
We had some like grad students, they just wanted to see like how fast of a plane they could make. And so they did like a stiff blue foam and then like 1 or 2 layers of fiberglass, and then it didn't even have a spar or anything.
Wow.
It was just the foam and then the structural skin because of the composite.
Okay.
And then it went like 100 miles an hour.
Damn.
It was pretty wild. They just put like a fuck ton of lipos in it, and then like had just like a balsa tube fuselage, kind of like the design that's suggested here. And then they were really precise about like rounding the edges and, like I was saying, hiding the tube inside. And so in the fall, y'all could check out that cute little plane. But
Okay. So that's another option, doing just the foam. Because I mean, we could also strengthen it by having, can we bore out stuff? Is that like an option?
if you wanna.
Because you could probably either bore or cut out like a place for a spar to be put in, like a carbon rod?
Yeah, I mean, what you would probably do if your foam wasn't enough for the shear, and foam is all right in shear, and so it might not be an issue. Like I was saying, sometimes you'll have a foam wing and then you'll just put caps on top. But I have seen, oh, also when we talk about leading edge D-box, you can also do a foam leading edge. But then you wouldn't get the torsion, structural rigidity. But we're not really familiar with the load, so we don't know if that's a big deal or not a big deal, but
Right.
it's another option. But what you can do is you could just, you know, we've got our like hot wire CNC for the airfoil profile, and then you just like cut it, right? And then you put a sheet in and then like epoxy it.
Okay.
That's how you can fit that in. We do have a little router.
Okay.
But the thing about like routing out too much space, and I think for my year's mock comp, we wanted to store our payload in the wing and have like a really minimal fuselage. And so I'm trying to think, I think we cut out, it was foam, and we cut out a section and then we reinforced it with, we put balsa. So it was like a balsa box,
Okay.
right? And then we had like the rest of the balsa spar coming out and like mounting to the box, you know?
Right. Okay.
And so whatever that was. And then we had little like hockey pucks. And then we just like put a cover on it, you know?
Interesting. So I know Vlado is trying to go for slats, and I don't think we're gonna have enough expertise to do slats on our plane. But we could definitely do flaps on the.
Slats are when it like comes out the front, right? And there's another.
Yeah,
kind
I
of
don't think we're gonna be
profile.
able to do that.
We've done it before, and Spence said it's not hard, but Spence is graduating and won't be
Yeah.
around.
He's taking all the knowledge with him.
Yeah, I don't know. Because we can't build in person. There's just, I feel like there's a lot being lost.
Yeah.
But at least we're not graduating. Oh, it sucks so bad if like all of us were graduating and then this was like, y'all would show up in charge of the lab and you've never seen the lab before.
That would not be good.
So
Yeah, that would not be good.
okay, yeah, it'll be better. Okay. Yeah, I don't know. I think it's complex. Spence said it's not that hard, but another high lift device like you saw on that plane was the like fences,
Right.
you know, and those will mess with your like stability because now you've got air pressure acting like wherever your center pressure is here, you know.
Got it. Okay. Interesting.
But yeah, there are options. You could we don't have that method refined. I think somebody tried once, but we didn't get very far. So there definitely have to be research if you wanted to like rely on that to be good.
Okay. Cool. I definitely think we could work off either foam or balsa wood for our wing. What about fuselage? Would that just be, or our main spar for the to connect with the tail? Would that's going to be probably a composite that you're thinking of, right?
Yeah, we were thinking that composite tube for the boom. So what you can do if you wanted to have, I think balsa makes sense for the box. It's really easy to make a balsa box.
Right.
Simple. But then the drawing has this like totally enclosed shape going all the way back to the tail and stuff.
Yeah.
And so you could have that with a boom, but also you could not have that.
Couldn't you just have like a little bit of a little bit of taper so we're not like creating a vacuum and then have just a yeah, like that.
Yeah. So that'll depend on you if
Right.
because there's weight savings if you get rid of that. But like you said, then there's low pressure over there, so
Have
you
like a
can
little
figure
bit
it
of
however you want.
yeah. Because also, couldn't you just drill holes through that composite to hold the vertical and horizontal stabilizers?
Yeah, I guess so. If you're
Okay.
thinking maybe if you like bolt it in from
Yeah,
like
so
inside the tube.
you could put make the vertical stabilizer and just put that through the spar, and then at 2 different points make like here, I'll have to draw it. It's too hard for me to explain. We have like that's one wing, the spar goes in the middle, second, and then we have our what is that called? You know what I'm talking about, our elevator.
Mm,
Um,
yeah.
And so our spar is, oh, it's not a good color. So this would be our spar, and then this would be up here. This would be up
Takes
here.
a second to load your drawings, but I think you might have called this the spar, but that's the boom.
The boom, yeah.
Yeah.
Cool.
Yeah,
And
we've
build these like this, and then this is connected, of course.
and we do say drill, but that might be like a little balsa stick.
Right, yeah.
Yeah, something like that.
There's something to connect it through.
Yeah, a bunch of people do what they want to do with tail connections. So it's good to think about tail connections because this is round. You know, you could print
Right.
something if you didn't want to try to mate to a round surface, and so you could do a little print and then have a flat top, and you can do whatever you want with that.
Couldn't you also do like something that like hugs the surface and then build that? So like we're looking straight at the you have your verticals like right here, and then you know what I'm saying, this would be bigger actually. It would be like that, and
Like this is a cross section
yeah,
of the boom because your boom is probably hollow.
right. Oh, okay.
Yeah. Sorry if that made it like more confusing, but that's why I said that.
Oh, okay. But yeah, okay. I think we're thinking similar things. So
Yeah.
is this looking like towards the side of the elevator or the horizontal?
Which one?
What is this one?
I cannot see your mouse.
But the drawing.
This was also head on, like the same view, I think.
Oh, okay.
So there's your tube and the cross, and so
Wait.
and
Oh, this is the tube.
have your horizontal thing. Yeah, so this is a tube, and this is a blue is a printed thing that goes like around the tube, slide it in from the back or something.
Oh, I see what you're saying.
Some way, either you're again gluing that surface or
Right.
downward.
Okay.
Yeah. So there, and you can also spoof on other planes. You can see how people do the tail connections.
Right. Would it also be, or would there be any benefits to have like a little bit of this for more like airflow, or
for aerodynamics?
yeah, or more support? Because
I don't know. I'm not sure I've seen. Sometimes we'll have instead of having like a I think that one might be worse. Sometimes we've had this, we've had like this shape or something. As like this guy, you know, but
Right.
I don't know, since it's like so flat, you know,
So
like
what?
if the air was coming like this way,
Right.
it would make a big difference. But since it's since these airflows are kind of independent of each other, when it hits that surface, you know, like tapering it in this direction isn't gonna make a huge deal, I don't think.
Okay.
Technically, you could get some flow that wants to go sideways, but I don't know.
Very minimal. Okay. Okay. Whoa. Okay. Cool. I don't think there's anything else I have questions on.
Yeah, and you can also make tail either out of foam or of balsa build, and balsa build is really tedious is the thing. And if you crash and you break it, then it's a big deal. Whereas foam is really easy to replace. So those are some things, and you might want to like post in the mock comp and get some people's opinions before we like jump in. But also if you wanted to look at that code that I sent and then just update it. I don't know if they picked an airfoil and then they can tell you the thickness that you're working with, but then I think you'd have all the parameters, you know, put in your 8 pounds, choose your safety factor, and then at least you have your balsa spar. And if you choose to do something else, then we can use a different methodology. But
Right. I might see if someone can pick that up because I have never used MATLAB before.
oh, well, I made it theoretically pretty easy, like I said.
Okay. Is it
If
just
you're not
infinite
trying to
of-
change the methodology of it, literally all you do is change these inputs and you run it. The rest of the computation just is for balsa, for an lift distribution. And if you're not changing those things, you can even change well, the thing would be if you're doing foam and then you're not an I-beam, you're like solid, you know, and so then we would have to think about modeling and modify it a little bit. But if you want to modify it, if you want to use something that is not, then we can do that in next meeting, and I can modify these a little bit for that. But otherwise you can just run it.
Cool. Awesome. I think we're all good to go. I don't think there's anything else. I would ask if anyone else asks questions, but no, it still says Jake is here. That's just so weird.
I'm really not seeing it.
Because it says 2 participants for me, but then it says me, you, and Jake on the breakout rooms.
It's not there.
Do you not see that? Here, I'll take a picture. Watch, it doesn't show up on my camera. Oh no.
It's a ghost.
It could be. Here, I'll send it in the mock comp. I'll just direct it to you.
If it's good enough, you can put it in memes. I think some people have it looks like they chose an airfoil, so
Yeah. No, I'll just send it directly to you. It's not good enough for me. It makes no sense though.
Yeah, I
And
don't
now
know.
everyone can see it, so we're good. Jake, where are you? Are you still here? Okay. Sounds good.
Yeah. See you next time, I think.
Yeah, next Thursday. Hopefully Jack comes. Jack, if you're watching this, please come to the Thursday. May 6th. Yeah, May 6th. So, all right, sounds good. I'll see you.
Yeah.